Well, g'day, it's Ken Colson here. We are back. Today I've got Dr. Marcus Ross again with me. Marcus, how you doing?
I'm
Great
doing
to have
really
you.
well. Thanks for having me on again, Ken.
Fantastic to have you on. So Marcus, again, he's the CEO of Cornerstone Educational Supplies. So I'll put a little logo up for that, and people can go check that out if they would like to go there. Some great stuff there. He's also a fellow for the Center of Creation Studies at Liberty University as well. So, Marcus, welcome back. We are looking today at this kind of internal, I don't know, squabble that we have with creationists, different models, looking at the flood, post-flood boundary. So there's been quite a bit of stuff written. You've actually written a number of papers on this topic, and we're going to look at a few of those papers today and see if we can kind of tease out some interesting data. So maybe I just give it over to you, and you can kick us off here and tell us, what first of all, what's the problem, and what do you think are some of the solutions?
Oh, thanks, Ken. When we take a look at this issue of the flood generally, one of the questions that we've always had in creationism is when does the flood begin and when does the flood end in the geological record? And not just any local place. Like if, you and I went out to where I'm at in Lynchburg, or, we went over to Loma Linda where others are, we could look at those rocks and we might think, okay, maybe these are flood rocks or post-flood rocks or pre-flood rocks. But if we try to back up a little bit and see more of the whole of the geological record, from units like Cambrian, Ordovician, Silurian, all those things like Cretaceous and Triassic and the Cenozoic, those sorts of terms that we find on the geological column, there have been a number of different proposals over the years for where the flood might start in that, anywhere from down deep inside the Precambrian to the Precambrian-Cambrian boundary, or above that, as you've made some good arguments for. And then we have a question of, well, when does the flood end? If we go back to, say, something like Whitcomb and Morris in their 1961, the Genesis flood, they would have argued that the flood ended just a little bit before the Ice Age, and that there was an Ice Age after the flood. Other young Earth creationists think that the flood goes all the way up and through and includes all the Ice Age stuff as well. Others say maybe it's a little bit lower down, where, say, the boundary between the end of the dinosaurs, the beginning of the Cenozoic and the mammals start. Some have even put it even further down. So we've had a lot of models that have been put forward over the past, century, really, in young Earth creationism about where the flood boundary might be. We could take this all the way back to actually the beginning of stratigraphy with Nico Steno, who gave us the rules of superposition and original horizontality, the very basis by which, you and I learned how to do stratigraphy and learned how to do sedimentary geology. Steno was a devout Christian, and he looked at the rocks in the nearby alpine regions where he was, and he divided them into creation week rocks, flood rocks, and post-flood rocks. So it's very natural for those who have a creationist perspective of this, going all the way back to the 1600s, to look at the rocks and say, can I sort them out into time bins that represent the world that was, the world that was destroyed, and the world that we're now in? And within young Earth creationism, starting with Whitcomb and Morris, we have kind of this, what we often call a high post-flood boundary, something just below the Ice Age. But then you get to 1994 with the publication of the catastrophic plate tectonics model, the Austin et al. Paper from that year's ICC, and they proposed that the end of the Cretaceous was actually more likely to be the end of the flood, and that would mean that the Cenozoic, what is traditionally called the Age of Mammals, would be a post-flood recolonization period, and they made a number of different arguments for that. One of the arguments that has frequently been put forward by all people concerned on this is that there should be some sort of break between the types of fossils that you find below in the flood rocks and the sorts of animals that then recolonize the world after the flood is done. Since all land-dwelling, air-breathing creatures, everything that was nephesh, had to be brought on board the ark, then everything else was wiped out. Then we've got this, dispersal from Ararat, or the mountains of Urartu, and going out into the rest of the world. So given that there's kind of a sweepstakes of animals expanding out into the world, we might not expect there to be a good correspondence between the last of the animals that are buried during the flood and the first of the animals to reach a new world, so to speak, after the flood is done. So most writers in creationism, going back to Whitcomb and Morris and on through to today, have puzzled over what that should look like and how sharp that distinction, that break should be. And we see people writing about this, let's say even going back to the 2008 ICC, John Whitmore and Kurt Wise talk about an early post-flood mammalian diversification in the Green River Formation, the Eocene Green River Formation,
Mm-hmm.
and they make some comparisons to what's below there, and they're saying this is, part of the evidence of that sweepstakes, and that would put the flood boundary down around the end of the Cretaceous type of thing, somewhere below the Eocene. In 2012, I published a paper that tried to approach this from a more quantitative approach. And my paper was published in the Journal of Creation, so one of our journals that deals with technical publications. And it was titled "Evaluating Potential Flood Post-Flood Boundaries with Biostratigraphy." And so, for those who aren't familiar with that term, biostratigraphy means that we are looking at the types of animals and plants, the biota, if you will, inside the layers of rock, the strata. So biostratigraphy is the life inside the rocks, dead life at this point, and tracing the types of patterns. What sort of organisms do we see? What sequence do we find? Can we compare the sequence in one place to another? And biostratigraphy was my background for my PhD. I looked at a group of animals called mosasaurs, big marine swimming reptiles. And my dissertation was all about charting the changes in those organisms as you march your way up through the layers in which they're found. This is all about biostratigraphy. So I wanted to bring my expertise in that area to the question of what about this boundary issue? So what I did in this paper was I asked the question, if we take the high post-flood boundary argument just below the Ice Age at what we might have as a division between the Pliocene rocks below and the Pleistocene rocks above, and we use that as kind of a basic benchmark, how many North American mammals cross through that boundary? Things that would have to be dead and buried during the flood and then would have to come back to the exact same continent. And in most cases, actually the same basins, the same depositional areas, the same state, et cetera. But I didn't get that fine detailed on the paper. I was just asking, do they come back to North America? Mm-hmm. And I looked at over 300 genera. So if you're, folks are remembering, you've got your species, and species are lumped in genera, and then genera and families. You got your kingdom, phylum, class, order, family, genus, species. So I was looking at the genus level and asking how many genera cross from one layer to the next, and would have to make this kind of return trip to walk and live on the rocks of their dead ancestors. Mm-hmm. Not necessarily where their dead ancestors lived, but simply where their dead ancestors were buried. So that's even a little stranger, Mm-hmm. And what I found was that it turned out that nearly 1 out of 4 North American mammals came back to North America in that study. It was 23.6%. So, nearly a quarter of all of the mammals that I looked at. Now, I looked at fairly large mammals. I didn't look at rodents. I didn't look at insectivores that would have ballooned the study up. But also one of the reasons why I didn't look at the small stuff is that reworking, kind of exhuming and redepositing small little bits of tooth and whatnot are highly possible in the rock record. So by taking a look at the animals that were generally a little bit larger, things like rhinos and camels and horses and cats and dogs and mastodons and whatnot, we'd be looking at stuff that would be much harder to rework without obvious evidence of reworking. Mm-hmm. So looking at that for North America, I kind of looked at that and said, 1 out of every 4 genera returning back to the continent on which their dead ancestors were buried seems really, really high. Moreover, most folks within young Earth creationism do not consider the genus to be the level of the biblical kind. Rather, most of us think that something like the family is the representative of the biblical kind, or thereabouts. Could be a little higher, could be a little lower, but is a good first approximation. So this would mean that actually all but one of the families that I looked at, and I looked at 28 North American families in this group, all but one of them would return back with several, with at least one or sometimes several genera. So what this looked like to me was, hey, you can't have, say, 4 genera of one kind taken aboard the Ark. You can only have at most 2, like one genus here that's a boy, and one genus that's a female, and maybe you can cross those, but you're not going to have something like 4. And yet we've got 4 crossing genera in something like the pronghorn antelopes. There are multiple species of them in the fossil record. We only have one alive now. But I saw the same pattern show up with the felids. Lots of felids, like 9 genera of felids crossed this potential boundary. And so by looking at this one, I kind of said, from the standpoint of the fossil record, a high post-flood boundary seems to be precluded because we have too many animals in the kinds, first off, but also we have too many things returning back to the same exact locations, or what seem to be at least the same continent.
And I just importantly, they are, some of these mammal groups are only found in the same location in so-called pre-flood and post-flood deposits, right?
Right. So the pronghorn
that kind of accentuates the issue. It's not like they're in other places. This is the only place you find them, in pre-flood deposits, so-called pre-flood deposits, and then it's the only place you find them in post-flood deposits.
Yeah. So in my study, I noted that with a couple of things. So the pronghorn antelope family is called Antilocapridae, and they are endemic to North America. We have no pronghorn fossils anywhere else in the world. There's just none. They're only in North America. So for 4 pronghorns to cross the boundary means that there's got to be 4 North American pronghorns that go on the Ark and then come back only to North America and nowhere else in the world. And that seems very, very unlikely that they wouldn't stop and go somewhere else. Some of the other genera are more gregarious, and they're more found across the globe. So you might find something like the genus Lynx, which crosses the boundary. It's one of the cats in North America, but it's also a cat that is in Asia. So we've got, Siberian lynx, and we also have Canadian lynx. So that one, you could at least make the argument, well, maybe it came from Ararat and went through Asia and came to North America. So there are some that you might say, okay, that's a possibility. But the lynx is one of, again, like 7 or 9 cats genera that cross the boundary. So Noah's no longer bringing a pair of cats. He's bringing a whole bunch of them.
Right.
And that seems to be very, very problematic with what we know biologically, because at least in the present, including the lynx, all the genera of cats that we have alive in the world today can be connected to one another through a network of hybridization. This cat can mate with that one, and this one can mate with this other one. And eventually all the genera alive today, 60 some odd species of cat, can be connected through interbreeding and hybridization. Since hybridization is a classic evidence of being part of the same biblical kind in creationism, going way back, especially to the writings of Frank Marsh, for example, then this would seem also to be a component that would exclude this type of high flood boundary, because now you've got to bring multiple members of the same kind that are already capable of interbreeding, at least in some capacity. That seems to be pretty wrong.
What do the proponents of the high flood boundary have to say about that? I mean, I know, Anstongenesis generally are one cat kind, one dog kind, and I know that they're a sort of a Cretaceous PG boundary group. But what do these other advocates think about that?
Well, Mike Oward has been the most prolific writer on this from the standpoint of a high post-flood boundary in dealing with some of the biological issues. You also have Tim Clary and Jeffrey Tompkins, for example, at the Institute for Creation Research. They've done a lot more on the geological argument. Mike Oward has written a lot about the geological issues as well that he thinks compel us to a high post-flood boundary. But to his credit, he has also been trying to deal with these paleontological and biological types of issues that have been brought up by me, and especially also by Chad Arment on this. Oward seems to be of the opinion, and I've spoken to a couple other folks who haven't published anything on this yet, but we've been kind of chatting. They seem to be of the opinion that maybe there is a mechanism by which nearly identical genera and species could be developed in the post-flood world, so that you've got this bottleneck, and you've got only so many members that are brought on board the Ark, two of the kind, and 7 pairs for the clean kinds type of thing. But let's keep it at something like cats. And so you've got all this diversity of cats that's buried in the flood, and 2 are brought on board, and they think, well, maybe there's a genetic mechanism that can make effectively what look like clones of the stuff that's below, that it will redevelop lynx-like structures or tiger-like animals that are paleontologically indistinguishable from the ones below.
Wow, I hadn't heard that before. That, when it comes down to plausibility, right, that just seems very implausible to me.
Yeah, it is. And Chad Arment had a very good paper in which he kind of discusses those issues, and he kind of graphs it out a little bit, if I remember correctly. I'm not sure if it was his ruminating on the Ark kinds. Might not be. That's a tongue-in-cheek title, as he talks about the clean animals, the ruminants, and how many you would have to bring on board the Ark if you've got to bring the level of the kind down to the genus. I think that might be, I'm not sure, but I think that might be the direction that, say, ICR might be going. Some of the writings that I've seen from Clary and Tompkins on this seem to indicate an openness that maybe we shouldn't be looking at the level of family, because there's maybe too much evolution that has to happen, in a sense, after that. So maybe if we drop down to the level of the genus, then we can bring along 2 lynx and 2 panthers and 2 small cats of the genus Felis and the like. My issue with that, and Chad Arment's issue when he looks at this with the ruminants, is this very rapidly multiplies the number of organisms that have to be brought on board the Ark,
right,
to the point where, as I said at the ICC this past year, NOAA needs to make an armada rather than an Ark. Right, yeah. He's going to need a fleet of different Arks to hold all this stuff, and that's simply not possible. So we know that he brings animals on board the Ark. That means there's a reasonable number of organisms. As our knowledge of the paleontological record has expanded, that has put pressure on young Earth creationists to think about what that kind happens to be. Is it just the species, or is it the genus, or is it something bigger than that? And when I, with a student at Liberty University, looked at this as part of a senior research project, we did a quick tabulation that if we took the family level, we would end up with something between 900 and 1,000 different kinds that would need to be brought on board the Ark. Somewhere around 2,000 to 3,000, but probably 2,000 to 2,500 animals,
which is doable.
That's very doable. It's a Herculean task for NOAA and his family, but the Ark can fit that.
Yeah.
The Ark, I don't think, can fit hundreds and hundreds of ruminants, not to mention now thousands upon thousands of unclean animals to go along with it.
Yeah. Again, with plausibility. Yep.
Yeah. So what I'm seeing with Mike Oward and perhaps even Taz Walker, although I'm not sure, is that kind of that openness to maybe that you've got iterative evolution, in a sense, iterative diversification that ends up looking like the stuff before, which I think is biologically implausible.
Yeah.
Or you have the argument, well, if we reduce the kind down to the genus, then we can still hold our high post-flood boundary, and they just happen to come back to the continents that they do. I don't care if it's 25%, but there's only so many continents anyway. It's kind of Tim Clary is his quick argument there. And then I think we run into the problem of needing multiple Arks.
Yeah. So you've talked now. There's 2 major areas there of major implausibility, right? Getting the Ark, these critters on the Ark, either that example, or somehow they're able to, like you say, reproduce exactly the same kinds of genera from before the flood, which to me seems incredibly implausible. So that's one whole implausible argument. and then the other one where you have the same kinds of critters coming back to the location they were before the flood. They're two massive areas.
Yeah, they're difficult. And after my paper was published in 2012, Taz Walker and I had a debate in the pages of Journal of Creation, a little back and forth on that, which was very nice and good and substantive. Walker is much more like Mike Oward. He'll make the argument that the geological column is generally accurate, but has lots of specific problems. What I find is that allows them to kind of try and dodge out of any particular, line in the sand, and then say,
Right.
well, maybe they cross here, but they don't cross over here. And, so you end up with this flood boundary that is completely locally identified,
Yeah.
and doesn't have some sort of even, large scale regional or continental signature. And I think, it doesn't help them in the end, even though they're trying to say, well, maybe it could be in various places. It doesn't matter where you put it. You run in the Cenozoic into this kind of problem.
Yeah.
Chad Arment approached the same question from a different angle. He's a biologist. And one of the things that he argued early on, back in, I think it was 2014, was that if we took a look at the fossil record of animals that are known to hybridize and follow them back until there's only one genus of the hybrids around, that's got to be the point where, that's the earliest place where the flood boundary could be. So he looked at this with a group of snakes in North America and said, okay, we've got these couple of different genera and they're known to hybridize, so they should be part of one kind. Let's take a look in, say, Nebraska or Kansas, and where we've got a good fossil record of these things, and follow them back down. And, going past the Pliocene down into the Miocene and into the Oligocene before you're finally at one. He's like, well, that would be, the highest point, the lowest point you could get before you start saying, here's where the flood is. It could be even further down, but it can't be any higher than that, I should say. It can't be any higher than that. So that was an interesting way to approach the question as well, from the question of hybrids. And that would work for things like the cats as well. It would work for, a number of bears, anything that we have hybridization records for. We could, that are, the types of animals that would go on the ark. That's a plausible way of looking at what might be the flood boundary.
Okay, excellent. Any other papers there or stuff?
Yeah. I mean, this argument has, it really started to roll a lot. I don't want to take too much credit with my 2012 article, because it was, it's part of a longer discussion, but it really did seem to get a number of people irritated, which is okay. Right. And to their credit, then they brought their arguments, and now it's kind of open season and you see a good number of papers. So it was kind of, the dam burst, and now we're all kind of talking about it. Arment has had a number of papers. Not only did he have the paper about the snakes and the hybridization, he took a look at the fossil record in Australia and asking the question, getting things from places like Australia to the Ark and then back again, because, as you well know, the fossil record of Australia, it's very, very unique. You've got marsupial animals that are not found on any other continent aside from, maybe nearby in Indonesia and, things like that.
Yeah.
But it's highly restricted. We don't find kangaroo and wallaby fossils. We don't find, Tasmanian tigers, Tasmanian devils anywhere else in the world. And so he took a look at that with marsupial fossils in both South America and Australia, the two best examples of that. And found results very similar to mine, and then also calculated, well, what would the odds be to bring them all back again if this high post-flood boundary is where it would have to be? And the numbers are, astronomically small. They're, 10 to the minus 20 some odd, 10 to the minus 30. They're just not going to happen.
Right.
They're not possibilities whatsoever at all. Some have argued that in a discussion with Nathan Moak at the ICC this year, he said, listen, you got animals that are tied to each other ecologically, and so you can't treat all these animals as if they are singletons and just calculate out the improbabilities on a 1-to-1 to 1-to-1 to 1 type of thing. He thinks that, okay, you've got, ecosystems that are interconnected to one another. And so some of these actually collapse. And the probabilities, he told me, are going to be much, much lower than what you think. And while I recognize that, yes, there are certain components of ecosystems that are in fact linked together, right? You've got obligate pollinators and flowers, for example.
Right.
That does not hold for most organisms, right? It doesn't hold for most predators, for example. Some predators do have obligate prey. But if we, again, think about something like cats, cats are a very adaptable group of animals when it comes to what they will eat. Basically anything smaller than them, right? They'll eat chipmunks, they'll eat squirrels, they'll eat mice and rats, they'll eat lizards, they'll eat snakes, they'll eat insects, they'll eat anything. So if I'm going to be calculating what the odds are of a certain cat genus coming back to North America, it's not tied to any other thing. It doesn't have to be a predator of only this species of chipmunk.
Yeah.
And likewise, you've got a group of kangaroos of various sizes and wallabies, right? And these animals, they don't have to live together.
Right.
There's nothing that requires them to interact with one another out of necessity. And so I would expect that I should be able to then calculate them individually or as a singular species, genera, whatever our bin happens to be. So I don't think the argument that the interconnectedness of an ecosystem collapses these remote possibilities into something that's more like the role of maybe a 10-sided die.
Yeah.
That's
especially when we're talking
systems work.
Even high post-flood advocates recognize we're in a completely different world. All niches are gone. It's brand new. And so to tie them together like that in both completely different environments seems, again, highly implausible.
Yeah, I agree. I know ecosystems emerge right out of organisms that find themselves in a place. And I'm not talking about some sort of evolutionary emergence here. Just even if we think today about the accidental introduction of species, right? Where you live, with the introduction of the rabbit, drastically changed Australia's ecosystem. And within 100 years, it was across the continent, pretty much everywhere. And they introduced cats. That changed things dramatically. In the fossil record, we can also see when North and South America finally connected again. We have something called the Great Intercontinental Faunal or the Great Faunal Interchange of the Americas. And it's where in North America, we get things like armadillos. And in the fossil record, we got giant ground sloths. Those came up from South America, and South America got stuff from North America like cats. And cats went down to South America. They kicked the snot out of everything. They did tremendous damage and became top and mid-level predators where other things used to be.
Right.
If one thinks that the post-flood boundary is lower than the point where North and South America connect, if you think that it's above that, then you have to explain some really weird, biogeography in that type of situation. But, those are some papers that have been published subsequently to mine, and more just keep rolling out. So in 2023 or the end of 2022, Mike Oward decided to revisit my original paper and rerun the analysis. And so he hopped on the paleobiology database, which had changed quite a bit in the intervening 10 years or so. And he was looking at North America and looking at the genera. And he came up with pretty much the same data that I did, or the same results that I did. There were some changes. There were some, taxa that are no longer valid or, were cleaned out of the database. There's new ones that are put in. Right. And that happens. You and I both know, as science progresses and these databases that are available to everybody, people load up new information and they check on stuff and remove stuff. So, I was kind of surprised because Mike Oward runs the analysis, gets pretty much the same results that I do. 20 some odd % of the genera come back to North America. And he says, this is perfectly compatible with a high post-flood boundary. And I kind of go, I don't see how that's the case.
Yeah.
There are a few sorts of things that he argues. He doesn't think that we can really ultimately trust something like these databases, like the paleontological, paleobiological database, because all the data is input by evolutionists who have an evolutionary worldview.
Mm.
And unfortunately, like, that's all of science, right? If you can't trust that, there's no reason to trust any of the basic descriptive data about a geological, section someplace, studied core or an outcrop. There's no reason to trust, somebody going out and describing a new species of animal, because chances are they're an evolutionist. So if you follow this logic, you end up with, kind of paralysis. There's nothing that you can trust.
Right.
And I kind of hope that God's common grace to all humanity means that we can discover things about the world that are real, even if we are not paying as close attention to his word as a guiding light to us.
Right.
So I can't follow in with that kind of skepticism to the databases. My own data is in the paleobiology database. I hope that it's right. Some of it's no doubt wrong. I probably made some mistakes.
Yeah.
But as somebody who's worked with those types of databases and contributed to them, it's an accurate, usable thing with the occasional errors that are common to our human condition. And so I can't go for kind of, using it and then saying, well, it's probably not really usable.
Yeah.
Because I've got, these other things that I think compel me to a high post-flood boundary. And that's the trouble that all of us are in on this, is that we all think that we've got certain types of evidence that count a lot and other evidences that we don't think count so much. Right. Usually those are the ones that don't work for us, right, as well. Yeah. And so, I'm a paleontologist, and so I think the paleo data is really important. And there's other data that go maybe against my position that I put down a little bit, because I think, well, yeah, but these data are really, really informative.
Yeah. I read Clary Tonkin, I think their paper, the 2023 ICC paper, and Ord's 2022 paper. And I wasn't at all convinced in any of the paleontological explanations that they gave. Now, they did weigh in heavy on some other criteria that they think is important. One of them being erosion. What do you think about that? I mean, it seems to me that their biggest concern, that the largest concern, is the amount of erosion that we see in the post-flood world. How would we answer that?
Yeah, that's a good observation. And, in our discussions, I see Tim Clary, we see Mike Oward at meetings and whatnot. And they're good guys. And, I've known both of them for many, many years. In discussions with them and reading their work, certainly the erosion issue is a big one. How do you carve, say, Arches National Monument or Bryce Canyon, if not for the flood? How do you create the features of the grand staircase of the American West if it's not for the flood? And to add for that, with Tim Clary also, how do you create the vast thicknesses of Cenozoic strata? There's just, in some places, 10, 20,000 feet worth of Cenozoic strata, especially, in places like Oregon and Washington, right off the coast of the Cascades. And there's tens of thousands of feet of Cenozoic, and they look at that and say, that's just too big. It's got to be the flood. And, for something like that, I think young Earth creationists have a couple of options if they're going to say, no, the flood boundary's got to be lower. We do have to account for huge amounts of erosion. We do have to account for huge amounts of sediment deposition. And Steve Austin once said, he felt that when Noah got off of the ark, most of the world was the consistency of mashed potatoes. And, a little tongue in cheek, but you certainly kind of get it, right? This world was waterlogged, and lots and lots of your superficial materials are going to be very, very unconsolidated. They're going to be really loose.
You had another one about slippery wet fish as well, stacked on top of each other. Yeah.
That I can see. He was probably talking about that in the context of bathtub modeling and, using glitter sticks and stuff like that. Great. But if we think about mountains that are rising towards the end of the flood, like the Rockies, like the Cascades, like the Alps, the Himalayas, if these are composed of sediments that are hardened hardening and stuff that isn't really hardening yet, there's going to be a lot of opportunity for erosion to, to create those sediments that are deposited elsewhere in those massive thicknesses. How much time do we have is an open question. And, you and I aren't here to talk about, Masoretic versus Samaritan Pentateuch versus are there gaps in the genealogies or whatever. But there's a range of potentials for young earth creationism to think about how much time is there in the time between Noah and Abram. And it's anywhere from only a few hundred years to 1,000+ years to, maybe a lot more, depending on how tightly you take your chronologies. So I think one of the things might also be, if you're convinced, as especially the folks at ICR and well, to that matter, also CMI and AIGR, that the Masoretic text must be read completely tight, with not only no gaps in the genealogies, like there could be gaps in the genealogy, but no gap in the chronology.
Right.
You've got that fixed chronology, then you've only got like 390 years between the end of the flood and Abram. And that's not a lot of time to get much done.
Right.
So the higher that you put the post-flood boundary, the less you have to accomplish.
Right.
You have some ice age sediments, and I'm not even sure how you build the ice age in that amount of time, but nonetheless, you develop an ice age, and that's kind of it. You get humans spreading out, you get Neanderthals and Homo erectus and all that sort of stuff that we talked about on your channel on another occasion. But if you put the flood boundary really, really high, then there's very little that they think they have to put in that next few hundred years.
Right.
But if you put it down lower, now you've got to explain the Cenozoic mammal record as part of the post-flood world. And that's a lot more events. It's a whole lot more events. And so every once in a while, I'll get criticized for that. William Lane Craig tried to take me to task for, all the things that have to happen in the 400 years. And I never said I took the Masoretic text as a tight chronology.
Right.
But the general assumption is that you do, and I understand why that is. And if so, then you got a lot of work to do. And I don't know that there's enough time for all of that in that perspective.
Right. But given a chronology, maybe given 1,000 years, say, I think you're right. I mean, given isostasy, you can have mountains growing within decades to a century after the flood. And if that's the case, and you've got all this unconsolidated, unlithified material, I can totally see that being a cause for tons and tons of mass movements of sediment, moving sediment hundreds of miles even, and causing thick assemblages of sediment. I mean, what do you think about that? I see that as plausible given the kind of situation we're envisioning for a flood.
I think so. And one point that I tried to bring up in the panel discussion at ICC, they had, like 7 of us or something like that up there to talk about flood boundary. You were there, I was there, Tim, Mike, and several others were there. And one of the things that I said at the end of my presentation was that some of these issues are mechanistic ones. How fast can we get mountains up? How fast can we erode things? How far do things need to be transported? Those are mechanistic problems. What I'm worried about with something like the fossil record and these, returning critters is an existential one, right? If we change this, then all of a sudden I need 12 arcs, and that's just a no-go, right? That's impossible. That is an existential problem to young Earth creationism. Something like, I can't understand how we could erode so much of the American West and deposit 10,000 feet of sediments off the coast of the Olympiad Mountains. I look at that and say, mechanistic problem, not existential. So why don't we try and work on expanding our thoughts about what those mechanisms could be? And leave the existential problems where they are. And if we don't have to try to adjust those, great. We have these other levers that we can pull and take a look at and see what they can do. And remembering that, we are finite individuals. We don't have all the knowledge that we want right now, certainly. We don't have all the knowledge that we could have. And there's a whole host of future theoretical possibilities out there that, could provide us with explanations for these sorts of things. So even if it means holding something in tension And in creationism, we do this, but everyone does this, right? We find, out something and we hold really, really firm, and we find these other kinds of problems, and we want to hold on to those a little bit more loosely because we think that there's a possible solution for this.
Yeah.
Right. It could be anything in science. It could be anything in history. It could be anything in home economics, right? It's just, we do this as part of a normal part of being human beings.
Yeah.
We believe things about the Bible and we believe things about God, even though we don't understand them. We understand that there could be resolution either now or in the hereafter, where we finally understand, oh, this is what is meant.
Yeah.
But, you don't give up on the Trinity because you can't conceptualize the Trinity. You accept the Trinity and understand, for example, in this case, that God is greater than my conceptualization can be. But then there might also be some other things in the Bible where it's like, okay, I know this happened, but I don't know how or why or how this seeming contradiction is going to work out. And then it turns out maybe 500 years later, somebody solves that, with something like, oh yeah, Daniel and Nebuchadnezzar and Nebuchadnezzar's son, turns out, oh, it was co-regents. There was a king in between that wasn't mentioned. Right. It solved the problem of this isn't actually Nebuchadnezzar's son. The book of Daniel says it is. It's like, oh, wait, no, it turned out it's his grandson, and they use the convention term son anyway. Yeah. So, all right, this is a point that was in the skeptic's corner for a long time until it wasn't. Yeah. And there's plenty of things ahead of us for all of us where that's going to be the case.
Exactly. Yeah, I really agree with that. I like that whole idea of a mechanistic concept that we can look to. Okay, so that's I think that's their biggest issue, is the issue of erosion. And there are lots of plausible explanations for the erosion. However, like you said, when it comes to the biostratigraphy, it's just highly implausible. And so like you, that would be my plea to our fellow creationists out there to really be thinking about what's plausible and what's not plausible. Look, are there any last things that you want to talk about, Marcus? Anything else that we haven't covered?
Well, a little bit. We've talked about Tompkins and Clary's paper at ICC, and we've talked about a couple of the things that are actually at the end of their paper. The substance of their paper was that they were making a paleontological argument for the flood and its correlation to the megasequences that Clary has documented. And it goes back to the Sloss days of the 1960s. But Tim Clary has done a lot of work in trying to trace out these megasequences, these big packages of sediment with predictable patterns of sandstones, followed by shales, followed by limestones on these kind of continental scales. And he's mapped them out in a lot of places. And this paper was its goal was to try and show that paleontology matches this really, really well.
Right.
And as I've read the paper over the past couple of days and tried to spend a good bit of time with it, there's a couple of things that trouble me about it. One is, as you get to the tertiary and you get into this question of where the flood ends, they'll show you a couple of illustrations. I'm going to try and share my screen here so that I can talk about these and your folks can see them. All right, so this is the final figure in their paper, figure 20. And I'm going to start from the back, and then I'm going to hop back just a couple of pages to do a comparison. This is a really interesting figure. So what they did is they gathered data from the paleobiology database and looked for instances of brachiopods. So brachiopods are little animals that live in the water. They have two shells like a clam, but they're a completely different animal inside. So the thing to remember about these is brachiopods live on the bottom of the seafloor. They have a little muscle that comes out of the back of their shell and holds them in. And so these are animals that don't really move anywhere. And they sit and just filter water and pick up food particles. So we've got the 6 megasequences. The Sauk is the first one. This starts around at the base of the Cambrian or a little bit in the Precambrian, depending on where you happen to be. And then you go into the Tippecanoe, Kaskaskia, the Absaroka, the Zuni, and the Tejas. So those are the 6 sequences, and they're going to be stacked on top of one another. We have, for example, a lot of the Jurassic and the Cretaceous in the Zuni, and we have the Cenozoic primarily in the Tejas. A little bit of the Paleocene is still in the Zuni, but it's mostly all Cenozoic here. So one of the things that I find interesting about this is, when you look for brachiopods, when you look for marine critters in these sequences, you find there's a lot of them, and they are distributed widely over the continents. So, in the Cambrian, we've got brachiopod fossils and rocks all over the eastern seaboard of the United States, all over the Rocky Mountain areas, a few things in the middle. Mostly, there just aren't Cambrian rocks shown here, so we don't have the fossils there. But everywhere where there's Cambrian rocks, there's brachiopods, right? And they're across Asia and lots in Europe. You don't have a lot of data from South America or Africa or much from Australia. So for the viewers, these big blank areas are mostly just no data.
Okay.
Of much of anything, right? You can see that as you go from one to the next, looking at Africa, there's very little data of anything, right?
Mm-hmm.
And that's all right. That's just saying we got some big blind spots. We don't know the geology in these areas very well.
Yeah.
You keep going up through the section into the Ordovician and Silurian, and again, there's brachiopods all over, everywhere on the continents, in the middles of of what are now the middles of the continents. Same thing as you go up. By the time you're in the Absarica, you are into the Permian and the Triassic. So we're now getting into the Mesozoic and Jurassic and Cretaceous Zuni. And then you get into the Cenozoic, and all the brachiopods, at least in North America, are found only on the coast. Over here, they're found in the Caribbean. You find a good number in Central Europe because there's a lot of flat areas of Central Europe that I think were probably still underwater after the flood was technically over, after Noah was out. But the rest of the distribution of them, you see, like, okay, right along the coastline of Japan, southern coast of Australia, along the coast areas of South America and New Zealand. There's no brachiopods in the middle of North America, which is the most well-studied group of rocks in the entire world. Right? If we know rocks anywhere on Earth, we know them in Western North America, because there's no trees. We can find anything we want. Right? Yeah. It's great.
Yeah.
So they argue, however, that this is still part of the flood. This is as the floodwaters are receding, but not post-flood. They think that the Zuni here, basically the Jurassic and Cretaceous, represents the high water mark for the flood. And this is where the floodwaters deposited the last of the brachiopods. I find that a very difficult argument to make. I would expect there to be brachiopods somewhere in the middle of the country if they're coming out as the Rocky Mountains are popping up. Now I want to quickly scroll up to this one. So this is figure 18. Just above this is the distribution of Cetacea, the whales in the Tejas. So cetaceans are also marine organisms, but unlike brachiopods, they can swim, right? They can go all over the place. They're not stuck to the bottom of the ocean, but their distribution is almost identical. Right. Their distribution in North America is all along the coast and a slight embayment around the Gulf, right along the West Coast, the Caribbean. Similarly, you've got a lot of low spots around in Europe where they're found. But again, coastal areas of Australia and New Zealand, South America, you don't find a whole lot of them in the interior of the continents. So why is it that their explanation for this is that the whales bloated and floated away to the continental margins.
I read that. I saw this as well, and I was so not convinced by that.
No, how do you end up with the same pattern of two marine critters, one that is mobile and one that is sessile? And they're saying, well, one bloated and floated. Like, well, okay, but that doesn't work for your brachiopods. They don't bloat and they can't float because they're covered by a hard, denser than water shell. So when we've got two independent things that are pointing at the same direction, I think this is telling us that we were definitely in the post-flood period here. Now we have whales that are, being killed in minor local catastrophes, or, being beached up in places. Their fossil record appears to be post-flood. That does give us hard questions as an advocate of where are they and why are they not in flood rocks? And I don't have a great answer for that. But nonetheless, the pattern here is whales are found in the marginal areas of the continents in the places we know the best. And there's a lot of low-lying areas of Europe that could conceivably be underwater in the post-flood world. Aside from that, you're looking at, coastlines and estuaries as the only places where whales are found.
I saw this data and I was like, this is this supports the lower flood boundary. This is data that's actually supporting a lower flood boundary.
Yeah. Yeah. And the whole time in the presentation, we're being told, and in the paper as well, this matches perfectly with the mega sequence data. It worked perfectly with the mega sequence data. Well, it maps onto your mega sequence data. I can understand why they say that. They see their mega sequence, say here, right on the eastern seaboard of North America, and they see the whales are here.
Yeah.
So in their mind, that says, okay, that matches perfectly. But notice over here, and I'd like to, maybe kind of end my discussion, at least of this paper here. They've got the mega sequence of the Tejas invading the entirety of the Western United States. Now, there is, granted, we're young Earth creationists, and we think the flood did cover the whole world, and most geologists don't agree with that. You certainly won't find a geologist in the United States that's going to agree with this map of the Tejas mega sequence. Everything in here is considered to be terrestrial deposition by conventional geologists and paleontologists.
Right. Yeah.
You've got the White River Badlands with all mammal fossils. You've got the Wasatch Formation that you had just mentioned, right, is in there. The Oligocene Formation, like the Brule Formation. All of this stuff is very, very terrestrial. There are occasional marine-ish looking critters that show up once in a while, like you might find in the Green River Formation. You see every once in a while there is a ray, or something that looks like it might have had an oceanic connection. But the vast majority of everything that's in there is actually very terrestrial, right? You've got horses in there, you've got palm trees, you've got insect fossils and other places up over here. And that tipped me off to a concern. And as I was reading the paper, the problem that I ran into is this. The mega sequences are defined by geology. They are marine mega sequences by definition in the conventional literature. You can't talk about the Tejas if you're talking about something like the Green River Formation, because it's not a marine unit.
Yeah.
So the sediments out over here on the Atlantic coastal plain, where I'm located, if I go just outside of Richmond, Virginia, we get into marine units over here, and I can agree the Tejas is represented here and down into the Gulf. What Tompkins and Clary do, however, is they equate any and all sedimentary rocks with their mega sequences.
Right.
And that means that a paper like this is ultimately circular in nature. The fossils match the mega sequences because they are defining the mega sequences not on the definitions of marine units that are identified as marine, in part by the fossils, right? But rather, anytime we find these packages of sediments, no matter what their fossil content, we're calling them part of the mega sequence. And so one of the things that that Clary brought up that is a hard question for us is, where does the arc land if all of the Middle East is underwater and you've got limestones over here? And limestone is typically formed in marine settings. It can be formed in terrestrial settings. The Green River Formation in Wyoming has lots of limestone, and it's terrestrial. It's, as far as like it's an interior lake type of structure. But the problem is that I have is, if Clary and Tompkins and the others at ICR are willing to call all these things marine in order to bolster their argument that the mega sequences are explaining all of the geology, then I honestly cannot, for the life of me, trust that these maps in the places where we know less about the geology are actually accurate.
Well, actually, I've done some research on that as well. And it turns out that a lot of those sediments are not limestones. A lot of them are sandstones, and a lot of them are volcanics. There are tons and tons of volcanics there. So it's not as simple as these are all limestones.
Yeah, a highly dynamic environment where you've got multiple plates that are moving. So not shown on this map because that's not what they were trying to do. But you've got a plate with Africa, you've got a subplate with the Arabian, you've got a plate with Europe, you've got subplates in here. And as those are moving, that is going to be the source for that dynamic, assemblage of geology that you're talking about, that we have, all sorts of different things happening, subduction zones, collision areas.
So that's important.
Yeah, it is. It really is. And so while I can agree with with Clary on some of his megasequence maps. The problem of circularity looms very large when you read this paper carefully. And it's especially evident in the first few megasequences because they take a look at marine fossils like trilobites, sponges, bryozoans, and things like that. And they compare them to the megasequence maps, and there's a great correlation between them. Well, of course there is. You're looking at marine fossils and comparing them to a marine megasequence system. There better be, near perfect correlation between the two of those. But then you've got terrestrial stuff, and they start to talk about that later on with the dinosaur material and whatnot. And I find that the analysis is just too coarse and too quick to argue for their own position, and too quick to make a claim that something is part of a mega sequence when it isn't. There's, and I'd mentioned that at the end of my talk at ICC, that there is no Tejas mega sequence in the central Western United States. It's not there. It's around the margins. It's down around the Gulf. It's out over on the edge of California. It's on the eastern seaboard of the United States. But, look at this thing that's a blob around like Indiana and Ohio. That blob of color is not part of a mega sequence. It doesn't even have a connection to the ocean. Right. So it's just a group of sediments that are in the Cenozoic that are being assigned. And you can see the same thing in South America and in Africa. You've got these packages of sediments that are simply being assigned to the mega sequence, but they're not marine and they're not connected to anything marine. Right. And that is something that causes me great pause in listening to some of the arguments that are presented for this high post-flood boundary.
Yeah, I agree. And, he did say, talking about the Cenozoic fossils as well, he talked about the Cenozoic fossils in terms of stasis, that the Cenozoic mammals, I should say, in terms of stasis. What do you think about that?
If we're taking a look at the record of the, just classic, the record of the horses or the camels or the rhinos, these classic North American mammals that are usually used as examples of evolution. There's a good reason why they're used as examples of evolution. The first horses show up and they've got multiple toes. They have hooves. They have other skull construction that is recognizable as being equine. But their teeth are in the right positions. They got the right numbers of them, but the teeth look dramatically different because the first horses are browsers that are eating, soft leaves. And over the course of the stratigraphy, you see the animals get larger, their limbs get longer, the numbers of toes reduce, and the teeth transition into grazing ones, teeth that have to be able to handle coarse grasses that have lots of silica in it. There's these little things inside grasses called phytoliths, and it just means plant stone because they tend to absorb silica from the ground and they create these little hard nuggets in them. And if you and I were herbivores and we had to eat grass, our teeth would get worn down in a manner of a decade and a half easily, and we would starve to death as a result. But the equines, on the other hand, that are capable of handling this have teeth that have roots that are extremely long, that are 6 inches in length, and they'll keep growing upward. And it's only when you reach a horse that's probably pushing 30 years old that you finally get to the end of their tooth, and they can no longer chew. But their teeth are extraordinarily deep rooted to handle this type of material. So there's you can look at and see stasis in some types of animals at certain levels. But we've got to be very careful about how we discuss stasis and living fossils in the rock record. And actually, John Whitmore had a very good paper in a previous ICC dealing with that, and saw that most of the living fossils are actually Cenozoic. At the time when we start seeing genera that persist for long durations in the rock record. Mostly Cenozoic, some that are in the flood sediments, but most of them actually in the post-flood sediments, where they haven't changed that much. But stasis is not something that is like a persistent pattern everywhere you look at it. Only if you look at a rodent and say, well, it's a rodent. Like, well, yeah, and it does stay a rodent, but it looks different, from here to there. And that's the type of painstaking detail that we've got to be able to do for ourselves. If we're going to explain these data, we've got to get into the weeds as deep as they go. When I was a grad student at South Dakota, I had to be able to take a partial jaw of a horse and tell you what genus it belonged to on the basis of 3 teeth, right? That was part of the exam. That
Right.
was what you had to do. Is this a rhino? How do you know it's a rhino? Explain the features on the upper molars that are telling you this, why, and then at least give me the subfamily of rhino that it happens to be, right? If you can't get to the genus, bonus points if you can.
Yeah.
And in my discussions with some of the folks that hold to a higher post-flood boundary, like Mike Oward, will say, you can't really do that. Like, no, you can, and I've had to.
Yeah.
And other paleontologists, Matt McLean and some of the others that have gone through it, Neil Duran looking at forams, and Kurt Wise looking at invertebrates. These are the types of details that are actually there in the record. And our first reaction when we find data that are difficult for us is to say they're not real. Right. This is across the board. Everybody does this. The first thing that comes up, it's politics. You get a poll you don't like, it's garbage. Well, that might be easy for you to say, but it's harder for you to deal with the data if it's done by Gallup or Pew or the really respectable polling agencies out there. You can't just say garbage and walk away. If we're going to have a good understanding of the world that God has made and the world that God has judged and the world that God has providentially saved through that judgment, then we've got to be willing to explore his world at a level of detail that seeks after his level of detail. And that none of us are prepared for that, but well, let's roll up our sleeves and see at least what our little minds can do.
Yeah. We've definitely got to try. Okay, so look, we've covered the gamut there. Is there anything else you want to add?
I'll take 5 minutes if you don't mind.
Yeah,
because
cool.
I just want to mention.
Great. We're going to cover the
mention
gamut on this, so this will be a good resource.
Yeah, I want to mention Kurt's paper.
Okay.
And not really go through it as much because it's not as easy to understand as the others, but it was published right alongside, and it's another Biostrat paper, so we should probably include that.
Yeah.
So an interesting study in contrast at ICC, because you had the paper from Tompkins and Clary, and their paper is big in terms of its perspective, right? They're looking at mega sequences, continental deposition, and when they look at fossils, they're looking at huge groups like Brachiopoda, right? That's a phylum. Or they're looking at Archosauria, the things that include dinosaurs and crocodiles and pterosaurs. It's a big, huge group of reptiles. Also, in that same ICC was a paper by Kurt Wise and Donna Richardson, in which they evaluated on a much more granular approach. They took the entire fossil record and broke it down into all of its subunits. So we might think of, say, the Cambrian and the Ordovician and the Silurian as the 3 units in the beginning of the Phanerozoic. Well, Kurt and Donna, they split the Cambrian into all of its subunits and the Ordovician into all of its subunits and everything all the way up, so that they were looking at hundreds of these and looking at the boundaries between each one. But not only that, the question they were looking to ask was, how many or how often does an organism in one bin, one of these little bins, cross over into the next bin above it in a geographic area next, either itself or next door to it? So they broke the world up into these 2 degree by 2 degree squares and plotted but ran all these analyses to take a look at how many creatures would have had to have come back to the same place, so to speak. So they took kind of how I approached it and then amped it up beyond anything I would have anticipated doing. This is really impressive. And saying, let's look at 2 by 2 degree areas, neighbors, and boundaries at a very fine scale in order to see not only where the post-flood flood boundary candidates could be, but also where the pre-flood flood count boundary candidates might be. So where do we see in the rock record where the flood might start? And they actually had a pretty big range of options for that. It was anywhere from about, on the conventional time scale, 1.5 billion years ago to up into the Ordovician or the base of the Ordovician. So this could see the Cambrian as possibly pre-flood. I know you think that might be a possibility there. There might be some reasons to think about it. These stromatolite difficult mound things that you've studied. But it could be the Cambrian, or it could be, so there was a lot of options in there. So in that respect, it was pretty interesting because now we can, we don't have like a single place where paleontology says it's got to be here. Now we can go in and make a lot of arguments from paleontology, from geology, from a bunch of things, and say what might be a good option. When he looked at this for the post-flood boundary, the results were a little bit more strict. And that was anywhere you looked in the Cenozoic, you had a huge problem of return taxa to either the same place or the neighboring area. And so he's looking at units of area, right? 2 by 2 degrees longitude and latitude, about the size of a state or province. And so I was looking at a whole continent, and Kurt and Donna are like, no, let's look at like Iowa, and does it come back to Iowa or Kansas or, Nebraska, right? And if it comes back to any of those, then this seems to be altogether too convenient, and is much more likely a post-flood type of situation. Or we're still in. So we're looking for some sort of biostratigraphic break. It's either in the flood and they're being buried one after another, or it's post-flood and things are developing and spreading. And their finding, at least for the post-flood, was there was basically nowhere in the Cenozoic that you could put it except for maybe part of the Paleocene. But again, that's right on top of the Cretaceous. That's right along with those coal beds. That's right along with one of the biggest biostratigraphic breaks we have in the rock record at the KPG boundary. The only bigger one that we have is the Permo-Triassic, and there's other reasons I think that probably that's not it. But that could be a candidate if you wanted to put the flood boundary way low and then have all the dinosaurs and everything else up. As post-flood. Some creationists have made that argument, a post-Permian type of thing. But nonetheless, it was interesting to see them take this type of numerical approach, high quality data, right? So Tompkin and Clary's, their approach is to try and get lots and lots of data. And this is kind of like different ways that you can do things in science. You can try and get a lot of data, and it's rather coarse because you're looking for really big patterns, and that's okay to do. And then there's other types of things where you're trying to weed out as much of the data as possible so that what you have left is really, really solidly known. And either way is a way to approach the question. So it is really interesting if you read these papers side by side to see them approach a big picture question from two very, very different approaches. And the answers that they come up with are very different as well. Very, very different. So I think, the technicality of Wise and Richardson's paper is quite high. It would be tough for us to kind of go through everything that they talk about with their stage boundary straddling species. They call these NLSSS. It's a good thing they have an acronym because it's a really long unit here. But when you see somebody do an analysis of the entire fossil record, substage by substage, or stage by stage, that's really impressive. It was perhaps, I think, one of the most impressive papers that I saw at the ICC that year. It was a real tour de force.
It was certainly an impressive presentation because I was there. It was difficult.
It's very along. Passionate. Kurt was really passionate.
He was.
That was great. It was a lot of fun to watch.
Definitely. So, all right, great. Well, look, I think we covered the gamut. So this will be a great resource for those of you out there who want to dig in. And of course, I'll be putting up papers and geologic columns and other bits and pieces. I'll edit these in later. So look, Marcus, fantastic. Always, man, love discussing these things with you. Love getting into these nitty-gritty areas. I love being critical. I mean, that's what I really like, to look at these things critically. So thank you. And no doubt we'll have you back on again. sometime in the future with some other topic, or maybe the same topic. I don't know. We'll figure that out as we go.
Yeah,
So
15 years worth of arguments over the post-flood boundary. I think we're good for a while.
Yeah, we're good for a while. We'll have something.
You're still doing this YouTube channel in 15 years. We can do an update.
Yeah, there you go. Part 50 or whatever it's going to be. Hopefully not. Hopefully we'll maybe resolve a few things between now and then. Marcus, thank you.
Thank you so much, Ken. Delightful to be on, and blessings to you and to all your viewers.
Cheers. Thank you. Okay, so for everyone out there, that's it. That's all from me, Ken Colson here, Creation Unfolding. Don't forget, please pound that like button if you thought that this video was in any way helpful. Go ahead and do that. Subscribe, ring the bell, easier access to more videos as they come. There is a link in the description for PayPal if you would like to give. That'd be great too. As always, appreciate prayer, and we'll see you next time. Thanks and goodbye.